Hi guys, my name is Minhajuddin Ansari and you're watching the 21st tutorial on C programming, and today I will be talking about array names and pointers. So the name of the array is actually a pointer that stores the address of the first element of the array, and I can prove that by first defining my integer array num of size 5, and I'm going to initialize it to 1, 2, 3, 4 and 5. And then I'm going to simply define an integer pointer, and I'm going to initialize it to the address of the first element of the array. So that will be the address of the element 1. So the name of the array is the same as the address of the first element of the array. So the name of the array is a pointer that stores the address of the first element of the array. And let's just check that out. I'm going to use my printf statement, and first I'm going to print the name of the array and just add a new line right here. And then I'm going to print the address of the first element of the array. So that is stored in the pointer variable ptr. So when I run the program, both addresses will be the same. That means the name of the array is actually a pointer variable that stores the address of the first element of the array. So, this just proved my argument, but now I'm going to slightly change the definition of the name of the array. The name of the array gets converted into a pointer that stores the address of the first element of the array. So it does not exist. It is not actually a pointer variable that stores the address of the first element of the array. It gets converted in most circumstances into a pointer variable that stores the address of the first element of the array. And I can prove that argument as well. So let me just, I'll prove that argument using the size of operator. And the size of operator simply returns the size of a variable. So suppose I have an integer variable a, and I'm going to initialize it to 5. So now if I want to know the size of the variable a, I can simply use the size of operator. So I'm going to write size of, and in between the parentheses, I'm going to pass my integer variable a. So when I run the program, this is going to give me 4 bytes because the size of an integer is 4 bytes in the C language. Similarly, if I pass a pointer variable to my size of operator, and when I run the program, this is going to give me the size of my pointer variable. And the size can differ in different computers. If you have a 64-bit computer, the size of the pointer will be 8 bytes. If you have a 32-bit computer, the size of the pointer will be 4 bytes. And if you have if you have a computer that has lower bits, the size of the pointer will be 2 bytes and so on. So the size of the pointer is different for different computers. So in this computer, in my laptop, the size of the pointer is 8 bytes. So now if the name of the array is actually a pointer that stores the address of the first element of the array. So if I write the name of the array right here, this should give me 8 bytes as well. So when I run the program, instead, this gives me 20 bytes. So in this case, the name of the array is actually representing the entire array. So this array has 5 integer elements, and each integer element is of size 4 bytes. So 5 times 4 is equal to 20 bytes, and 20 bytes is the size of the array. So in this case, num is representing the entire array. It is not a pointer anymore. So that's why I said, that in most circumstances, the name of the array gets converted into a pointer that stores the address of the first element of the array, but in some circumstances, the name of the array actually acts like the name of the array, and it actually represents the array. So in this case, it is representing the array, it is representing the size of the array, which is 20 bytes. And now I'm going to give you a second proof to prove my argument that the name of the array is not actually a pointer that stores the address of the first element of the array. So I'm going to use the address operator. And what I'm going to do is that first I'm going to write printf, and I'm going to print the address, and I'm going to print the address stored in the pointer variable ptr, which is the address of the first element of the array, which we have assigned right here. And now what I'm going to do is I'm simply going to copy this, and I'm going to paste it right here, and then I'm going to print the address of my pointer variable. So the pointer variable also occupies some space in the main memory, and it also has its own address. So I'm going to print that using the address operator on my pointer variable. And now what I'm going to do next, let me add a few new lines right here as well. So what I'm going to do next right here is that I'm simply going to print %p, and I'm going to print the name of the array. And in this case, the name of the array will act as a pointer that stores the address of the first element of the array. And then in the end, what I will do, let me just close this. In the end, what I will do is that I will print the address of the array. So I can do that by simply writing the address operator and simply writing the name of the array. So let me just run this program and let me show you what I mean. So right here, let me just minimize this first. And okay. So right here, the pointer variable, when I print the contents of the pointer variable, this will print the address of the first element of the array. And this printf statement right here will print the address of the pointer PTR. So it will be different. It will print the address of the pointer variable PTR, and this right here, this will print the contents of the pointer variable PTR, which is simply the address of the first element of the array. And this printf statement right here will, again, in this case, the name of the array is acting like a pointer that stores the address of the first element of the array. So in this case, the printf statement will print the address of the first element of the array. And in this case, it should, if this is a pointer, if the name of the array is a pointer, it should print the address of the pointer. But when I open my output, you can see that both of them are same. So again, at the top, this is the address of my first element of the array, which is stored by PTR. So this is the first printf statement, and this is the address of my pointer. And you can see it is different from the address stored in the pointer. This is actually the address of my pointer where my pointer is stored in the main memory. So then the address of the pointer and the pointer itself, they are different, obviously, because the pointer is storing the address of the first element of the array, and the address of the pointer might be somewhere else, might be located somewhere else in the main memory. But right here, this is where things get interesting. So right here in the third printf statement, the name of the array is acting like a pointer that stores the address of the first element of the array, and we are simply printing the contents of the pointer variable num. So in this case, we are printing the address of the first element of the array. And in this case, if the array name is a pointer, so when we try to print the address of a pointer, it should give us a different address. Just like this is different. The address of pointer variable PTR was different from its contents. Similarly, the address of the num pointer, which is the name of the array, should be different from its contents. But both of them are same. Both of them are same. That means in the fourth printf statement, the name of the array is not acting like the pointer to the first element of the array. The name of the array is actually representing the entire array. And when I apply the address operator, it will give me the address of the entire array, and the address of the entire array is simply the address of the first byte of the array, and the address of the first byte of the array is obviously the address of the first element of the array. So in this case, the name of the array is not acting like a pointer. It is actually representing the entire array. So this is all it. And just to recap, then in some circumstances, or let me say it, in most circumstances, the name of the array gets converted. Emphasis on the word converted. The name of the array gets converted into a pointer variable that stores the address of the first element of the array. But in some cases, the name of the array actually represents the entire array, as we saw in the size of operator and when we were using the address operator right here. So this is all about this tutorial. If you have any questions, please ask them in the comment section, and thanks for watching this video.